$1 billion. That is what a single THAAD air defense battery costs the United States. One of the most sophisticated shields ever built, designed to stop the most advanced threats on Earth. $20,000. That is roughly what it costs to build the drone that battery may be asked to shoot down. This is not a story about weapons. It is a story about mathematics, and about how one isolated, sanctioned nation rewrote the rules of modern warfare with machines that cost less than a family car. This is the story of the shadow in the sky. September 1980. Iraqi forces pour across Iran's border. The revolutionary government, barely a year old, inherits one of the most expensive air forces in the developing world. American-made, cutting-edge, and completely unusable. Western sanctions had severed the supply chain overnight. No spare parts, no maintenance. The F-14 Tomcats, pride of the Imperial Air Force, sat grounded. The helicopters rusted. The missiles expired in their crates. Iran faced a brutal choice: adapt or die. And deep in that crisis, a group of young engineers, students, mechanics, academics, began building something out of nothing. In 1985, amidst the war, the Mohajer 1 took flight. Mohajer means immigrant in Persian, and like an immigrant, it carried the hopes of people who had run out of options. It carried only a camera. Its range was tiny, but it was entirely, defiantly Iranian. The war ends in 1988 with no winner. Iran's military planners reach a clear conclusion: they cannot fight the United States or anyone head-on. They have seen what American air power does. So they build something else: 3 asymmetric pillars, swarming speedboats to threaten oil shipping, long-range ballistic missiles, and unmanned aerial vehicles. The Ababil, swallow in Arabic, the bird that defeated a great army in Islamic tradition, becomes the workhorse. Mass-produced, GPS-guided, capable of 8 hours in the air, and critically, built from Iranian components that no sanction could reach. By 2009, something happens that accelerates everything. An American RQ-170 stealth drone, one of the most classified aircraft in the world, comes down inside Iran. Iranian engineers reverse engineer what they can. They study geometry, the materials. They feed it into programs already running. The arsenal that emerges is not a single weapon. It is an ecosystem. Each drone is designed for a specific role, a specific cost, a specific threat. Of all of these, one stands apart: the Shahed-136. Its 2-stroke engine is adapted from a lawnmower. Its airframe is sheet metal. Its electronics are largely off-the-shelf commercial components. It costs approximately $20,000. A Patriot interceptor costs $4 million. Send 50 Shaheds, the defender must shoot them all down or let some through. At a cost ratio of 200 to 1, the attacker pays $1 million. The defender pays $200 million. THAAD is a marvel of engineering. $1 billion per battery, $55 million per interceptor. It is designed to kill ballistic missiles, objects screaming through the upper atmosphere at thousands of meters per second. A Shahed-136 moves at 185 kilometers per hour, a fast bicycle. This is not a flaw in THAAD. It is a flaw in the entire theory of high-end air defense. Systems designed for a Cold War adversary with intercontinental ballistic missiles, now confronting drones that fly under the radar horizon, follow terrain and cost a fraction. Iran's scientists understood this before the world did. They were not trying to build a better fighter jet. They were trying to find the seam in the wall, and the seam was economic. The story does not stop at Iran's borders. Tehran understood something that transformed the drone from a national weapon into a regional fact. Manufacturing knowledge can be transferred. Not just the drones, the blueprints, the production lines, the engineers. By giving allies the ability to build their own, Iran created something impossible to destroy: a distributed drone ecosystem. In September 2019, the world stopped underestimating this. A coordinated strike using drones and cruise missiles knocked offline the world's largest crude oil processing facility at Abqaiq in Saudi Arabia, briefly removing 5% of global oil supply. The Houthi movement in Yemen claimed responsibility and oil prices spiked. The world's biggest oil company, Aramco's market value fell by billions. 50-something machines, coordinated, had done what years of sanctions had not. But there is a human dimension here that the technical story often misses. Iran lost between 300,000 and 500,000 people in 8 years of war in the 1980s. That generation was consumed. The birth rate has roughly halved since. In a nation that carries that grief, that understands in its bones what it costs to send young men to the front, machines that can project power without putting Iranian lives at risk carry an enormous political logic. From a hand-launched wooden aircraft in 1985 to autonomous GPS-guided machines crossing international borders in 2024, the arc of 40 years tells us something fundamental about power, necessity, and ingenuity. 3 things have changed forever. First, the ability to strike at long range is no longer the exclusive property of superpowers. Any nation or non-state actor with a medium-sized workshop and a motivated engineering team can now reach targets hundreds of kilometers away with meaningful precision. Second, air defense is no longer purely a technological problem. It is now an economic one. The defender who must spend $200 for every dollar the attacker spends will eventually run out of either money or will. Third, the face of escalation has changed. When a drone is built in one country, assembled in another, and flown on a pre-programmed route with no pilot to capture, the gap between action and consequence, the space where diplomacy used to live, widens dramatically. The Zagros Mountains have watched empires rise and fall for 5,000 years. Each thought it had found the decisive weapon. None of them had. The drone is not decisive either, but it has done something more durable. It has permanently shifted the economics of war. And once a technology demonstrates it can achieve strategic effect at a fraction of the cost of the systems meant to stop it, that knowledge does not go away.